This is the second part of the Exposure and Exposome lecture. In Part 1, we defined exposure as how an individual or population comes into contact with an agent. The agent was defined as a physical, chemical, or biological entity that can potentially affect health. Exposure assessment is meant to also include quantification of the amount of contact that occurs across time and space. This infers that exposure can be both spatially and temporally varying. It can also vary between people and between groups of people. In Part 2, we will further discuss how we assess exposures. So how do we assess exposures? We can directly measure concentrations in the environment, such as in air, water, and soil. We can measure exposure to a person by having them wear a sampler or measuring a chemical marker in their body, for example, via blood or urine. Because it is not always practical and it can be expensive to do all these measurements, we often use mathematical models to understand how people are exposed. We can also model how this exposure is related to emissions of pollutants into the environment. There are two key factors that we need to assess exposure: the quantity of the agent in the environment, usually what we refer to as an environmental concentration, and the amount of contact a person has with the agent, usually referred to as an exposure factor. The quantity of the environmental agent can be ascertained by direct measurement, for example, through air pollution monitoring stations or analyzing water collected from taps or at the source. Sometimes we cannot sample everywhere or at all times, so we use models to predict what levels of pollutants we expect to find in the environment. As we said before, it is equally important to understand exposure factors, or how a person comes into contact with a contaminant. Exposure factors are defined as data on human behaviors and characteristics which affect exposure to environmental contaminants. These include time activity patterns, which say something about how long people spend in different locations, uses of different products where you might be exposed to a chemical, the kinds and amounts of foods you eat, and how much air you breathe. To illustrate how exposure factors affect the variability of exposure, we can see from this survey of time activity patterns in 4 European cities that people spend time very differently in each city. In Helsinki, for example, people tend to go to work and leave work at regular times with relatively little variability. In Basel, almost half the people go home at lunch. Also, in Basel, more people walk than in Helsinki and Athens, where more people use cars. These factors would be expected to lead to different patterns of air pollution exposure. For example, people who walk have different exposures to particulate matter or nitrogen dioxide than people who drive. Exposure changes over time. People often spend most of their time indoors, but this can vary greatly between individuals. Exposure to air pollution, for example, would vary because of both changing concentrations at different times of the day and year, and because people's activities vary accordingly. Exposure to contaminants also occurs through contact with skin and through eating or drinking. Ingestion exposures obviously include diet, but also non-dietary substances, for example, soil or dust, which may stick to hands. For these routes of exposure, assessors try to quantify the amount of exposure by evaluating the frequency and duration of hands touching surfaces, how much of the body comes into contact with a contaminant, and how likely they are to then transfer the contaminant into their mouth after touching surfaces. So now that we know that we need to know the concentration or amount of an agent in the environment and the amount of contact a person has with the agent to assess exposure, let's look at how we can use these two factors to calculate exposure. We will start with air pollution exposure. This refers to the concentration of an air pollutant that a person comes into contact with and could potentially breathe in. You need to know the concentration of the air pollutant of interest in each microenvironment. A microenvironment is a location where a person spends time. This concentration is multiplied by the time spent in that microenvironment. Because we spend time in different microenvironments, you would then add the product of concentration times time in all microenvironments of interest. Usually, we are interested in a time-averaged exposure. To obtain a time-averaged exposure, we would then divide the sum of concentration times time by the total amount of time you were interested in. Here is an example of how you would use the equation in the prior slide to calculate a person's exposure to carbon monoxide. In this example, a person carried a carbon monoxide monitor around with him for a day. You can see in the graph how the carbon monoxide exposure changes depending on where he is. Carbon monoxide is produced during combustion, so you would expect that if there are smokers, there would be higher values. Also, we see higher levels while driving. You can see the average concentration in each microenvironment, the amount of time spent there, and the time averaged exposure in each microenvironment. You also see the total time averaged exposure over 24 hours, which is 4 parts per million. For reference, the World Health Organization recommends that exposure be below 10 parts per million over an 8-hour average. So you can see that this person's exposure would be considered safe with reference to WHO guidelines. The previous calculation provided the time averaged concentration of an air pollutant that a person would come into contact with. If you were to calculate the mass of the pollutant that was actually breathed into the airways, you would have to also include the inhalation rate, which would be the contact rate in the equation you see here. Calculating intake makes it easier to estimate total exposure through multiple routes. This marks the end of part 2 and this lecture as a whole. Thank you for listening.